In this lesson, we're going to take a look at exponential functions and their graphs, concentrating on what we do when we have translations and transformations of the parent exponential function. So recall, an exponential function is a function that has a variable as an exponent. All graphs of exponential functions have certain characteristics in common, and I'll review those for you in just a moment. And given a basic parent exponential function, we can transform it. We have horizontal shifts, vertical shifts, reflection, stretching, and shrinking, just like we do with other types of functions. Let's review the characteristics of the basic exponential function f of x is equal to a to the x. We know that that function is increasing whenever a is a number greater than 1. And it's decreasing whenever a is a number between 0 and 1. Again, for the basic exponential function, the y-intercept is 0, 1. The graph has the x-axis as the horizontal asymptote. The domain, negative infinity to infinity, so any x value is okay for us to use. The range is always positive, 0 to infinity. There's no way to calculate a negative number. And the function is 1 to 1. Now let's look to see how do we do our translations on an exponential function. Here's our parent, f of x is equal to a to the x, and let's translate it and transform it. H shifts the function horizontally, left or right. K shifts the function up or down. The coefficient b stretches the function if b is a number greater than 1 and shrinks if b is a number between 0 and 1. Now when we say stretch for an exponential function, generally means that the curve that we have gets a little narrower. And shrinking means that curve is going to widen out a little bit. Also, b gives us whether or not we're reflecting. If b is less than 0, in other words, if it's a negative number, we'll be reflecting the whole curve across the x-axis. So we basically move it to the other side of the x-axis and flip it upside down. Let's look at a couple of examples. I've graphed a basic parent function, f of x is equal to 2 to the x, and let's see what happens when we do one simple translation. We're going to apply a horizontal shift, and recall when we do x plus 1, that means we're going to shift to the left by 1 unit. So we're basically taking our whole curve and shifting it to the left by 1 unit. There's no other translations. So a very easy way to draw our new function is to find a couple of reference points and then imagine them moving to the left by 1 unit. Now before we go ahead and draw that new function out, let's take a look at the basic characteristics. Like its parent, its domain, negative infinity to infinity, because any x value can be used. Our range, notice we're still going to be above 0. There's no way to calculate a negative value out of 2 to the x plus 1. There are no x-intercepts. We do not cross the x-axis. The y-intercept, even without the new reference points, as you see them there, we can easily calculate by plugging in a 0 for x. And our horizontal asymptote, just like the parent, is at y equals 0. Here is the original parent, f of x is equal to 2 to the x, and its translation showing a simple horizontal shift to the left of 1. Now as I go through the next couple of examples, think about, is there a translation which will cause that graph, that parent graph, f of x is equal to 2 to the x, to cross the x-axis, and if so, what would that translation look like? All right, let's walk through another example. Here is the parent, f of x is equal to 2 to the x, and I've drawn its graph as a reference. Now let's look at the translations. We have no horizontal translation. We also have no vertical translation because we're not adding a constant to the end of this function. However, we do have something else going on. We're multiplying. Our coefficient is a number that's bigger than 1, and so that means we're going to stretch that curve, and it's also a negative number, which means we're going to reflect across the x-axis. Now, in order to place our new curve, since it's not just one simple translation like our previous example, we really do have to find some points in order to figure out where exactly this curve is going to be. So one easy point to always find is the y-intercept. So where is our new y-intercept? Well, we plug 0 in for x. So we see that our new y-intercept is at 0, -3, and you can see that I just put a little blue dot down there at the bottom of the screen. Let's find a couple of more points. Let's see what's happening when we plug in a -1 for x and plot that point. And let's see what happens when we plug in a -2 for x, and we'll plot that point. Now you may want to find a few more points just to see how quickly that curve is going to be approaching 0. And here's a nice clean graph with their new function graphed on it, and you can see from the original parent f of x is equal to 2 to the x, we flipped it down across the x-axis, and we've stretched it so it's actually curving a little bit more quickly than the parent. So let's look at the characteristics. The domain, you can probably guess. Any x value is acceptable to plug in there, so just like the parent, -∞ to infinity. Now our range has changed. Our parent is all above 0. Our translated function is all below 0. So our new range is from -∞ up to, but not quite reaching 0. Just like the parent, we have no x-intercepts, we're not crossing. And in fact, convince yourself that we could not cross because there's no way to calculate a positive number out of this particular function. We've already calculated our y-intercept, and our horizontal asymptote is at y = 0, just like the parent. Let's try another one. First of all, what's the parent? F of x is equal to 2 to the x. Think about the translations. What are they? We've got a horizontal shift. We've got a vertical shift. We've got a reflection. And here are the two graphs, the parent and its translation. And in order to draw that translation, you will need to find some points, just like we did in the previous example. Once you've found those points and drawn the graph, then you can look at the other characteristics. Again, just like the parent, the domain is going to be -∞ to infinity. Now the range is a little trickier. The range is going to go from -∞ up to -2. We can see on the graph that we're not going to get any values that are going to rise above -2. And look at it algebraically. Can you think of a value that you could plug in there for x that would get you something bigger than a -2? There's no x-intercepts. We're not crossing the x-axis. We do have a new y-intercept, and if you plug a 0 in for x in the translated function, you'll calculate a -4, so our new y-intercept is at 0, -4. And our horizontal asymptote shows the limits on our range, and our range is never going to get above a -2. So y is equal to -2 is our horizontal asymptote. And that's it.